Hi, my name is Nick Tufillaro, and my partner is Aayod Kaul. This is our Machine Learning Lab video presentation for ME 435. Our primary objective of this lab was to create a predictive model that could using machine learning that could interpret accelerometer data and use that data to predict the specific movements of a user. So the five movements we were focused on were brush teeth, walking, lying down, pouring water, and drinking water. So today we're going to go through and explain how we collected our data, how we then dug through that data and extracted specific features that we thought would be useful, and then we'll talk about our machine learning model that we made and discuss how accurately it is able to predict the movements based on that accelerometer data. To collect our data, we're using the MATLAB mobile app, which utilizes the accelerometers in the iPhone or whatever smartphone is being used to measure the X, Y, and Z acceleration at any given time. We're placing the phone on the wrist to simulate the use of a smartwatch, and the wearer is then going to go through basic motions including brushing their teeth, drinking water, and walking. And the MATLAB app will record the X, Y, and Z accelerations for the duration of the motion, which will then be uploaded to the computer to be processed and analyzed. We are now going to simulate walking. Now that we have all of our data collected, I will walk through how we use MATLAB to extract the features that we wanted. So this function called extract ACK features goes through and takes the acceleration data called FID, and we first calculate the average acceleration in the X, Y, and Z directions, followed by the standard deviation in those three directions. Next, we find the average absolute difference in the X, Y, and Z, which is the difference between each data point and the mean. And then finally, we calculated the average result in acceleration. And this last part here is a for loop that computes the average time between peaks in X, Y, and Z by using the find peaks function and then calculating the time between peaks. Finally, we put all of this data in one big reference table to be sent to the machine learning model.
Okay, so now that we covered the intro and finished the data collection and data processing, it was time to be able to train our data. And to do this, we went to the classification learner and started setting up our model. In order to figure out what features we needed to use, the confusion matrix was created and several times to be able to see, based on our constraints given from the lab, we needed to have all of them above 75%. And we after some trial and error, using some PCA on some of them, maybe changing the features, going from 2 to 4 features. We finally decided on doing 4 features, and the way we went about deciding which features was kind of more on the simpler route, where we decided that, like, from the scatter plots, it was easy to identify it, the X, Y, and Z accelerometer data, and then combining that with the average results in acceleration, which kind of makes the most sense because, like when you're doing all of those motions in all 3 directions, you're probably going to get relatively different results for each one. So we chose that, and we didn't do any PCA, just because it wasn't really improving our results at all. So maybe overfitting in some cases, but anyways, like based on their 4 features, and the fine KNN network that we use, we got an accuracy of overall 85%, and each one over here was at least 75%, if not 100. And that's based on the true positive rates. So going back to a script, I already pre-ran this, and from our data that we collected, put in the test data, and then running the entire thing, and then doing the Y-fit, we were able to see that. Let me pull up the reference table. So obviously from the reference table, it's brush water, drink water, brush teeth, drink water, lie down, pour water, and walk. And only the first one out of the 5 it was recognized incorrectly. So it was pour water instead of brush teeth. So an 80% success rate was really actually turned out a lot better than we expected. Just because we're talking around and people who generally got 3 or 2 out of 5, and we're really happy about our results. Um, which makes sense too, because the way that our confusion matrix worked, at least 75% of all of them were good. And brush teeth, which is interesting because brush teeth should have gotten 100%, but it was marked incorrectly once. So maybe there's something there that we kind of, I guess in our like trial itself, we didn't distinguish between the processes enough to be able to like accurately determine that. That's the one thing that we thought of when we were discussing the results and interpretation. But regardless, like we're really happy with our results. And yeah, let me know if there's any questions. Thank you.